if we were to determine few things, for example, when we were saying velocity of the boat with respect to shore, right? So this is the velocity observed by a person from the shore. If you're on the shore here and you are observing this boat, you know, that's what the velocity of the boat respect to shore will look like. Okay? That is equal to, okay, that is equal to velocity of the boat respect to water. That is how fast the boat can travel in a bathtub with no currents. Right? That's how fast boat can travel in water without any current. Okay? And then velocity of water respect to shore is current. Okay, river current. So this is a good way of looking at how they can add relative motion. Okay, so here are the subscripts: velocity of boat respect to shore. Okay, so velocity of boat with respect to the shore, and then that is equal to velocity of the boat respect to water. So this is velocity of boat with respect to water. This means this is how fast boat can travel in water with no current. And this is the river current. Okay? In general terms, when you get to college, I guess, you're going to be learning more and other things other than boats and rivers. Sometimes, in more general terms, it is written as follows. V is equal to, okay, V prime plus U. Now this V prime does not mean take a derivative of. It just means it's different V. Okay? So what does that mean? Let's talk about like an airplane flying in the sky. Okay? This V represents the ground speed. Ground speed is how fast the airplane is flying when you're measuring from the ground relative to the earth. Okay? So this V prime is known as the airspeed. Airspeed is speed relative to air. Which means this is how fast the airplane will fly with no wind, like no headwind, no tailwind, no crosswind. Okay, this is how fast airplane can fly. But if there's any other wind involved, airplane can actually speed up or slow down depending on the direction of the wind. And this is known as the wind speed. And wind speed is speed of wind, right? Relative to ground. Okay? So sometimes this form is easier to use, okay? Or sometimes you could ask, like, okay, what if, like, you are inside a spaceship that is moving and you throw a ball inside the spaceship? Then this u would be the speed of the spaceship. This is the speed the ball is thrown inside the spaceship. And this will be the speed of the ball relative to the ground, or relative to the earth. Okay, so it's very important to recognize what's what. All right, so let's take a look at an example problem here. Okay, so here a boat points itself upstream 60 degrees from the shoreline, okay, in the river whose current is 3 meters per second. So here, the current river is 3 meters per second. So that's U, or otherwise known as VWS, velocity of water respect to shore. Okay? The boat is capable of traveling at 5 meters per second in still water. So this here represents the velocity prime, or simply velocity of boat respect to water. So you got to know how to identify these things. Okay? So part A asks, what is the velocity of the boat with respect to shore? So they're looking for V, B, S, or simply just V. Okay? So if we were to draw a little diagram, so here's a riverbank, okay? And our boat is heading 60 degrees from the shoreline. So it is heading this way, 60 degrees from the shoreline. So this angle here is 60 degrees. And this V is the V prime, or simply the velocity of boat respect to water. And we know that is 5 meters per second. But, and since it is heading upstream, the water is flowing this way, downstream, and that is my U, right? Or simply velocity of water respect to shore. Okay? Or simply, this is V prime. They want to know what is the V, or simply V boat respect to shore. They want to know what that is. Okay? So, to do this, you have to understand that V is equal to V prime plus U, or otherwise known as V boat respect to shore is equal to V boat respect to water plus velocity of water respect to shore. Okay? So the best thing to do is to figure out these velocities in Cartesian form. So let's draw this purple vector out, okay? If we were to draw this purple vector, which is v prime, and this v prime, which is vbw, is equal to 5 meters per second. This will have a horizontal and vertical components. So we're going to have VBWY and VBWX. And this angle happens to be 60 degrees. Okay? So if we were to find this, what is this? This is simply VBW times sine of theta, which is equal to 5.0 times sine of 60 degrees. So sine of 60 is 0.866. 5 times that, you should get 4.33 meters per second. And this will be y hat, right? So this is VBWY. Similarly, if you're looking at the horizontal component, which is VBW cosine of theta, and that is equal to 5.0 times cosine of 60 degrees, and cosine of 60 is 1/2, and half of 5 is 2.5 meters per second x hat, and that's my VBW sub x. So now we have our VBW in Cartesian form, and that is equal to, right, 2.5 x hat plus positive 4.33 y hat meters per second. Now let's take a look at u. Well, u is just simply going in the negative x direction, right? That is v of water with respect to shore. And that is just simply -3 meters per second in the x hat direction, and there's nothing in the y direction. So we can simply say VWS is equal to -3.0 x hat plus 0 y hat meters per second. And we will continue this on Thursday. All right. Have a wonderful day.